Hello and welcome to section 2.6b, rational functions and horizontal asymptotes, or just asymptotes in general. We're going to talk about horizontal asymptotes today and holes in the graph. Horizontal asymptotes happen when you have a graph that is a rational function and the powers it deals with the powers, and we'll explain more about this when you get to calculus, but we're talking about the degree of the numerator versus the degree of the denominator. And so if the degree of the numerator, so if I have something like x squared plus 3x over x cubed minus 9, the degree of the numerator is smaller than the degree of the denominator, so the horizontal asymptote shows up at y equals 0. If the degrees are the same, the leading coefficient degrees are the same, where we have like x cubed plus 6x plus 9 over 2x cubed minus 6x plus 18, or something like that, where the degrees are the same, we end up with a horizontal asymptote that is defined by the leading coefficients of the highest degree. So it would be a fraction of them, 1 over 2. So we'd have a horizontal asymptote at y equals 1/2. If the numerator's power is higher than the denominator's, where you might get like something like x cubed plus 6 over x squared minus 9, you end up with no horizontal asymptote. So your horizontal asymptote does not exist. We actually end up with an oblique asymptote, which is a diagonal or slant asymptote, and we'll talk more about those in the future. Finding holes in the graph, if I was to graph a function where I might have something like x squared minus 4 over x squared plus 3x, that's not going to work for me. I got to fix our function. X squared minus plus 3x plus 2, well, I would get a function that I could factor and end up finding holes in the graph. So whenever you have a rational function, start out by factoring, because if they're going to ask you for vertical asymptotes or holes or anything like that, first step you're going to want to do is factor. So I'm going to factor the top of this and get x plus 2, x minus 2. On the bottom, if I factor this correctly, I should get x plus 2 times x plus 1. And so now you'll notice that the x plus 2's top and bottom will cancel out, that creating a hole in the graph at x equals -2. So the hole comes from what cancels out. We still have a vertical asymptote at x equals -1, and you end up with a vertical asymptote at x equals -1 because that does not cancel out. So a hole happens when you cancel something out. A vertical asymptote happens when you can't cancel anything out in the denominator, and you set that equal to 0 and find out what your x value is. So that's what we're dealing with when we're talking about holes. We'll practice this in class quite a bit. And then when we put it all together, basically what you're going to do is you're going to start by factoring. You're going to cancel out any holes that you may have. You're going to set that whatever's left over equal to 0 and solve for your vertical asymptotes. You'll go back to the original function and look at the degrees of the numerator and denominators to find horizontal asymptotes. You can determine the domain and the range by the holes and the vertical asymptotes. The range will be basically figured out by the horizontal asymptotes, and then you get a pretty good graph. Probably other things you might want to find are like x-intercepts and y-intercepts to get a pretty good picture of what the graph is. And so we'll practice all of this stuff in class. Make sure that you copy this stuff down so that you know what we're going to be discussing in class. And if you have any questions, you can please ask in class.